The O3 molecule has a central oxygen atom bonded to two outer oxygen atoms that are not bonded to one another. In the box below, draw the Lewis electron-dot diagram of the O3 molecule. Include all valid resonance structures. 1 point is earned for a diagram that includes all 18 valence electrons and obeys the octet rule. 1 point is earned for showing correct application of resonance. Based on the diagram you drew in part A, what is the shape of the ozone molecule? The ozone molecule has a bent shape. 1 point is earned for the shape based on student's Lewis diagram. Ozone decomposes according to the reaction represented below. 2O3 gives 3O2 delta H standard equals minus 285 kilojoules per mole of reaction. The bond enthalpy of the oxygen-oxygen bond in O2 is 498 kilojoules per mole. Based on the enthalpy of the reaction represented above, what is the average bond enthalpy in kilojoules per mole of an oxygen-oxygen bond in O3? Delta H standard equals sigma, bond enthalpies, reactants, sigma, bond enthalpies, products. 4 equivalent bonds are broken in 2 O3 molecules. 3 oxygen-oxygen double bonds are formed in 3 O2 molecules. Let X equals the bond enthalpy in ozone. Therefore, 4x, 498 kilojoules per mole, equals minus 285 kilojoules per mole of reaction. 4x, 1,494 is equal to minus 285. 4x equals 1,209. X equals 302 kilojoules per mole. 1 point is earned for the correct determination of the number of bonds broken in the reactants and the number of bonds formed in the products. 1 point is earned for the calculation of the energy of the bonds in O3 consistent with bond counting, the bond energy of O2, and the delta H standard Rxn. Ozone can oxidize HSO₃ to the power negative, as represented by the equation below. HSO₃ to the power negative plus O3 gives HSO₄ to the power negative plus O2. A solution is prepared in which the initial concentration of HSO₃ to the power negative 6.4 by 10 to the power negative 4 molar is much larger than that of O3, 1.0 by 10 to the power negative 5 molar. The concentration of O3 is monitored as the reaction proceeds, and the data are plotted in the graph below. Visual. The data are consistent with the following rate law. Rate equals K1, O3. 1. Based on the graph on the previous page, determine the half-life of the reaction. 2. Determine the value of the rate constant, K1, for the rate law. Include units with your answer. 3. Considering the relative concentrations of the reactants, briefly explain why the data in the graph are also consistent with the following rate law. Rate equals K2, O3. HSO₃ to the power negative. 4. Briefly describe an experiment that could provide evidence to support the rate law given in part D. 3. 1. Half-life equals 0.010 s. 1 point is earned for the correct answer. 2. T1 divided by 2 is equal to 0.693 / K1 gives K1 equals 0.693 / T1 divided by 2 is equal to 0.693 / 0.010 s equals 69 s to the power negative 1. 1 point is earned for the correct value. 1 point is earned for the correct unit. 3. The data are consistent with rate equals K2, O3, HSO₃ to the power negative, because HSO₃ to the power negative remains essentially constant during the experiment. HSO₃ to the power negative can be contained in the rate constant K1. 1 point is earned for a correct explanation. 4. Repeat the experiment with a different initial concentration of HSO₃ to the power negative. If the change in the rate of the reaction is directly proportional to the change in HSO₃ to the power negative, then the reaction is first order with respect to HSO₃ to the power negative. 1 point is earned for describing a valid experiment.